Okay, welcome back, College Algebra. This will be part 2 of the 8-1 video. And in part 1, we had this lovely jumbled picture of an ellipse with all its parts. And the culmination of everything was we wrote the standard form of an equation of an ellipse with a horizontal major axis. Now, the last thing that I think I was saying at the end of the last video was that, okay, and you can take this to heart right now. Major axis, horizontal major axis and vertical major axis ellipses have equations that look just exactly the same. Here's the difference. You can tell that an ellipse is going to have a horizontal major axis if the denominator of the term with the x in it is larger than the denominator with the term with the y in it. Okay, so that's all you have to do to determine what type of major axis you're going to have, horizontal or vertical, is just look at the size of the denominators. And it's easy to remember. The x is bigger, it runs in the x direction. The y denominator is bigger, it runs in the y direction. Okay, now let's do this. We are going to actually graph an ellipse. Okay, so a problem like this might say something like graph x minus 5 squared over 16 plus y minus 4 squared over, let's go 4 equals 1. Okay, so there is the equation of an ellipse. Okay, if I graph this equation, it's going to make an ellipse. Now, let me say something here. You know, just like if I have the equation of a line, okay, I can graph it on a coordinate plane. And one way I can do it is simply to make an XY table. And if I make an extensive enough XY table, I'll be able to figure out what this ellipse looks like. But just like with a line, I don't have to make an XY table. Like if I know how this equation works, if I know that this number is the slope and this number is the y-intercept, I know that, you know, all I have to do is make it cross the y-axis here, and then use rise over run given by this number right here, you know, to go over and up or over and down and graph the equation. Well, same thing here. I can make like a really huge XY table and substitute in values of x and solve for y every time. And eventually I'd get to the correct ellipse. Okay, that's locus of points. I could connect them and make the ellipse. But if I know something about the way the equation of an ellipse operates, I don't have to do nearly that much work. So what I'm going to do to graph this is, the first thing I'm going to do is I'm going to write down the coordinates of the center. Teddy, make sure you can read this, okay? All right, so the center of this ellipse. All right, remember, the center is given by h and k. And if you look at the previous picture, h is the number that's right there after the minus sign, and k is the number that's right there after the minus sign. Now, so this is x minus h, y minus k. Remember, those minus signs are part of the formula. So the coordinates of the center here, the x coordinate is going to be h, which is 5, and y coordinate is going to be 4, which is k, which is 4. Okay, now if there were a plus sign here, for example, if this were x plus 5, then the x coordinate of my center would be at negative 5, right? Because that'd be x minus negative 5. Okay. Likewise here, if that were a plus, that would be a negative 4. Okay, and then the other things that I need to know, I need to know a and b. So I can tell that this is going to have a horizontal major axis because the denominator of the term with x in it is bigger than the denominator of the term with y in it. So this is going to be a squared. 16 is a squared. Now, if 16 is a squared, a has to be, well, the square root of 16. Okay, so a squared is 16, so a is 4. And then b is, that's b squared. 4 is b squared, so b is going to be 2. All right, so now all I have to do from there to draw my ellipse is I'm going to make a coordinate plane, and I'm going to put the center on it. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then Uno, dos, tres, cuatro, cinco, seis. Alright, I think I have enough tick marks there. Center's at 5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. I think my center is right there. Okay. And then from my center, I know that I have to go 5 units, or sorry, excuse me. I have to go 4 units left and right, because 4 is the length of my semi-major axis. So from my center, to get to the vertices, I have to go 4 units this way, and 1, 2, 3, 4, and 1, 2, 3. To get to my minor axis vertices, or the endpoints of my minor axis, well, here's the length of my semi-minor axis. Okay. Okay, go 2 units up, 2 units down. And then I just kind of connect these with a smooth curve to make my ellipse. Okay, and there's my ellipse. Now, a lot of times what you'll have to do in the assignment are things like this. It'll say, figure out where the vertices are. Well, there's a vertex right there. Can I figure out its coordinates? Well, yeah. The y-coordinate looks like it'd be the same as at the center. So the y-coordinate's going to be at 4. And then the x-coordinate is 1, 2, 3, 4 units to the right of the center. So 5 plus 4 is 9. So it looks like that vertex is at 9, 4. Of course, the other one you can kind of tell is at 1, 4. Listen, I can't emphasize this enough. Okay, to do a problem like this, draw a picture. Even if it doesn't say make a graph, even if it doesn't make a graph for you, draw a picture. Okay, it makes it so much easier to figure out where the vertices are. Okay, and as we'll see now, we're going to find the foci. Now, I haven't really mentioned much in the picture of the ellipse during the first video. I had the foci on there. The foci are always on the major axis. And if you look back to that picture, if you look at the first video, they are C units away from the center. But where in the world, how big is C? I don't know. Okay, so I don't know where to put C, where to put the foci here and here. But it turns out that there's a relationship I can use between A, B, and C for an ellipse that's going to allow me to figure out where the foci are. And that relationship, this is for ellipses only. Okay, and it looks like this. Oops, wrong letter. C squared equals A squared minus B squared. Okay, so you can write that down. That is the relationship between A, B, and C for all ellipses. So if I know any 2 of the value of any 2 of those letters, I can solve for the third one. And in this case, I think I know what both A and B are, so I should be able to figure out C. Well, maybe I'll do it right here. C squared equals A squared. Well, A is 4, so A squared is 16 minus B squared, which is 4. So C squared is 12, which means C has to be the square root of 12. So if I want to know, and pay close attention here, if I want to know where my focus is on the major axis this way from the center, I have to go C units, which means I have to go radical 12 units, the square root of 12 units. Well, the square root of 12, that's irrational. It's somewhere between 3 and 4, okay, because, the square root of 9 is 3, the square root of 16 is 4, so the square root of 12 must be between 3 and 4. So what I'd probably do is I'd go somewhere between 3 and 4 units to the right. So let's go 1, 2, 3, and then just some more. I mean, if you wanted to do square root 12 on a calculator to get a better decimal approximation, you can. And then, of course, I'd go the same distance the other direction, 1, 2, 3, and then some here. So the foci are pretty far from the center. This is a very elongated ellipse. We'll learn a better term for elongated here in just a little bit. Okay, so I put my 2 foci on there. Now, let's look at the coordinates of that focus. The y-coordinate of that focus, of course, is the same as the y-coordinate of the center. It lies on the major axis, just like the center does. So I'm going to put a 4 there for the y-coordinate. And then for the x-coordinate, well, I know that it's square root 12 units to the right of the center. And I am aware that square root 12 simplifies, and it would be 2 radical 3. Okay, where square root 12 would be the same as 2 radical 3 if you simplify it. So what I'm going to do then is for the x-coordinate, well, I'll start at the center, which is at 5. And then I'll add 2 radical 3. So for my x-coordinate, I'm going to write, and Teddy, make sure you can read this, okay? Maybe I'll stretch this out a little bit. This is going to be 5 plus 2 radical 3. Can you read that?
Sorta.
Sorta. All right. I'll try to write this next one a little bit bigger. This focus over here, of course, the coordinates are going to be, I'll write this nice and big right down here. Y-coordinate's still 4. And then the x-coordinate would be, well, if I start at my center at 5, here, the x-coordinate here is 5, I'm going to go left 2 radical 3. So that's going to be 5 minus 2 radical 3. Is that any better visually there, boy?
Definitely.
Okay, wonderful, wonderful. All right, so what I did there, what we did together here, is I had the equation of an ellipse in standard form, and we used it to find the center, find A, find B, put the center on there, use A and B to get 4 points around the center, graph the ellipse, and then I used c squared equals a squared minus b squared to figure out c. C tells me how far to go from the center to get to a focus. I did that. Now, if I encounter an ellipse with a vertical major axis, well, I do everything the same. The only difference is since if a vertical axis, if the major axis runs vertically, well, the foci have to be, instead of being left and right from the center, they have to be up and down from the center. Okay, so I would still find C the same way, but then I'd go C units up from the center and C units down from the center. Okay. Now look. Teddy, how are we doing time-wise here?
About 13 minutes, 30 seconds.
Okay. Let me say maybe one more thing, because there's like an entire additional topic that we have to talk about in this section, besides just what we've done. But let's just look at something a minute here. We're going to graph an ellipse. This is going to take care of 2 things here. Graph x squared over 9 plus y squared over 25 equals 1. Okay, so this is the equation of an ellipse. All right, now, does it look exactly like what we saw before? Well, not really. I don't have a binomial quantity that's being squared here, and I don't have a binomial quantity that's being squared there. Let's deal with that first. If all I have is an x squared, it's like h is 0. Okay, if you can't see a minus h, or minus a number up there, then h is 0, which means the x coordinate of the center is going to be 0. Same way in this case with the y coordinate of the center. Since there's no visible number, since this is not y minus a number or y plus a number being squared, it's y minus 0 squared, which means that the y coordinate of the center is also going to be at 0. So essentially the center of this ellipse is going to be at 0, 0 at the origin. Okay, so I'm going to write that center. All right, now, as far as A and B go, Well, you notice that this time the denominator in the y term is larger, so this is going to have a vertical major axis. And we still call that, we're going to call that a squared and that b squared. With an ellipse, we always call the larger denominator a squared and the smaller denominator b squared. So I'm going to write a squared is 25, so a is 5. B squared then is 9, so b is 3. So to graph this, what I do, okay, so the center's right here at the origin. Now, this is a vertical major axis, so I've got to go up and down 5 units from the center. And then left and right 3 units. And then I make my ellipse like so. Now, another way, maybe even simpler way to think about it is the square root of the x terms denominator always tells me how far to go left and right from the center. The square root of the y terms denominator always tells me how far to go up and down. And then you can just let the major axis fall where it may. Okay, I mean, if you just draw it like that, you'll figure out which way the major axis runs. Major axis in this case runs vertically since it's long, the ellipse is longer this way than it is this way. Now, of course, c squared is still a squared minus b squared, so c squared would be 25 minus 9, so c squared would be 16. So c is 4, so to get to my foci, I'd go up 4 and down 4 from the center. Okay, so one focus would be up here. Remember, so I'll go ahead and write this out. C squared is 25, that's a squared minus 9, that's b squared. So c squared is 16, so c is 4. And so I go, since the major axis runs vertically, I start at the center and I go c units up, c units down. And so you can pretty much figure out the coordinates of the foci from there. Now, listen, I'm looking at the assignment here. And I want to just tell you, let's see, 5. I think that you should be able to get through number 5 at least. I'm looking at question 6, and doing what we've done so far is not necessarily going to get you through question 6. Well, how are we doing time-wise today?
Like 18 minutes.
Okay. Yeah, why don't we shut this down for now? Look, I'm going to be honest, there are some more questions in the assignment that you will be able to do, but there's also some that you won't. When we come back, what we'll have to do is, the only equations of ellipses that we've seen so far have all been in standard form. Well, you can have equations of ellipses that are not written in standard form, but to graph them, we want to get them into standard form. So that'll be the topic for, there will be a part 3 to the 8.1 section, okay? But for now, enjoy, stay safe, thanks for watching.